Hey, third grade, welcome to science class on a Tuesday. And today our topic is going to be the scientific method. Now you might be thinking, I've never heard of scientific method before. This is going to be complicated and confusing. Well, here's some hope. When I don't know how stuff works, usually I try to figure out what the two different words mean on their own. So if we take apart scientific method, we have two words. Do we know what scientific means? So I can tell right away that the word scientific probably comes from the word science. And I know what science is. Science is a way of thinking. It's having a positive attitude and a curious attitude about the world and being able to test things for ourselves to see if they're true. Not just wait around and wait for an adult to answer a question for us. We can actually figure out things for us. Science can help us answer questions like, what is color? And where does it come from? And do we all see the same colors or different ones? Or what are x-rays? And why can I see my bones right now? Or are there really special cameras that can show heat on a person's body? Science is really cool in all seriousness, and it can help us solve a lot of interesting problems and satisfy our curiosity. But what about the word method? Well, a method means a way of doing things, or the steps you take to try to accomplish something. So when we put it all together, scientific and method, it's how do we do science to solve problems? The scientific method always starts with curiosity. Something that I'm curious about today is how to make my plants grow faster. Because right now, all I have is dirt. Step 2 of the scientific method is to figure out what we already know about how plants are supposed to grow. We talked yesterday, and we know that they need water. We know they need sunlight. We know they might take a little time to grow. And we know they need nutrients from the soil. Oh, and good seeds. So since there's not much we can observe yet, we'll have to wait on observations. But we are going to start with what we know. And I have a friend who I trust a lot that told me something funny yesterday. He said that plants like music and will grow faster if you sing to your plant every day. Now, I thought that was kind of crazy, but since I have a bunch of plants, maybe I can run an experiment to test and see if he's right. So the next step is to make a hypothesis. A hypothesis is basically an educated guess about how you think an experiment's going to turn out. So I really trust this person who told me that singing to your plants made them grow faster. So my hypothesis is that the plants that I sing to will grow faster and sprout sooner than the plants that I don't sing to. The next thing we have to think about is what variables do we have to control for? When we control for variables, it means we want to keep things the same. So sunlight is a very easy variable to control for my plants. I can put all the plants in the same part of my house in front of the same window to make sure they get the same amount of light every day. Water is a little tougher to control. Now, I can get a cup of water and be very careful and try to estimate the same amount of water for all the plants each day, but a much more exact way to do it, and the way a scientist would do it, is they would use a tool. So I'm going to fill up this quarter cup of water and make sure that each plant gets a quarter cup of water every day throughout the whole experiment. The next thing we have to do is focus on the variable that we change. So if I'm curious if plants grow better with music, I have to take half the plants and sing to them every day. The other half, I have to make sure I find a spot in my house where they can't hear me if I sing. So I have to put them away in a very quiet spot, maybe a closet, just for the time that I'm singing, and then bring them back in front of the window and water them just like the other plants. Next, we need time. I can't sing to my plants one day and expect them to grow faster. So I'll have to sing to them every day for the entire part that we're doing the experiment. So right now, I know that plants take 7 to 14 days to sprout. So I think a good timeline for this experiment is 10 days. I'll sing to my plants for 10 days straight at the same time every day. And at the end of 10 days, we can start making observations about how the plants are different. So now I have two groups of plants. I have my treatment group, and I have my control group, which is on the floor, and I can't get it. My treatment group, I'm going to sing to, because that is the treatment. The treatment is the singing. My control group, I'm going to do nothing to, and I'm not going to sing to them. Everything else is going to stay the same. Oh, and you have to keep the groups the same. You can't switch the groups up after 5 days. You have to keep the same 8 plants and the same 9 plants in separate groups for all 10 days. So that's most of the scientific method. After the 10 days, we'll have a bunch of observations that we can look at. We can measure the plants, we can look at their color, things like that. And then hopefully we'll come to a conclusion. Either my hypothesis is right, and singing to plants really does help them grow faster, or my friend was playing a trick on me, and I'll have tested it. Music doesn't help plants grow faster, or at least not my singing. So what's cool about science is that either way, if I'm right or wrong, I still learned something, and I did it by myself without having someone else tell me about it. So keep on watching for a Brain Pop video on the scientific method, and I will see you guys tomorrow. Don't forget to do the assignment in Google Classroom.
Yeah, I know you've been watering it. I'm not sure what's wrong. Dear Tim and Moby, what is the scientific method? From Marcy. The scientific method is the procedure scientists use to help explain why things happen the way they do. When people are trying to understand the world around them, they often come across problems that they just don't know the answers to. This is where the logical, step-by-step method of scientific problem solving comes into play. Like Moby here. He seems to be having a problem with his plant. The first step in scientific problem solving is to recognize the problem. Right. The plant is dying even though it's getting water every day. Why? To solve this problem, we first need to understand what we already know. Okay, plants need water. What kind of plant is that? Fig tree, right. Now we need to make some observations about the plant. The leaves are brown and falling off, and the soil is wet and squishy. Next, we make an inference. An inference is a conclusion about our observations. From what we've observed, we could infer that Moby is watering his plant too much. Now we translate our inference into a hypothesis. Well, a hypothesis is a testable explanation for the details you observe. What about, fig plants do best if you only water them once a week? Sure, it's just a guess, but after our observations, at least it's an educated guess. We'll need to come up with an experiment to test this hypothesis. Here's the plan. We've got 4 healthy fig plants marked A, B, C, and D. They have the same type of pot, the same soil, and they're getting the same amount of sunlight. The only variable, or thing that changes, will be the amount of water they receive. Plant A will not be watered at all. Plant B will be watered every day. Plant C will be watered 3 times a week. And Plant D will be watered just once a week. We'll check back in a month to see what's happened. What do you know, it's been a month, and I'm still wearing the same shirt. Let's record some new observations. Plant A doesn't look too good. Plant B doesn't look so hot either. Plant C looks a little better. Whoa there, Plant D is doing all right. Time to analyze our data. Based on this experiment and our observations, it looks like the fig plant did best when it was only watered once a week. From that, we can make a conclusion. Of the 4 watering schedules we tested, fig plants seem to grow best when they're watered once a week. Well, yeah, to be really sure, we should repeat this experiment several times, just to rule out accidents and variables we may have forgotten to consider. If the experiments don't support the hypothesis, then the hypothesis has to be rethought. Back to the drawing board, so to speak. But if lots and lots of experiments do support the hypothesis, then that hypothesis can eventually become a theory. Well, in science, a theory is an explanatory statement that's been repeatedly confirmed through experimental testing. If a theory is proven valid over and over again, it becomes an accepted piece of scientific knowledge. In the strictest sense, there's really no such thing as scientific fact. Scientists are always learning new things about the world around us, and you never know when they may find some new bit of evidence that forces us to redefine our understanding of the world. Right, using the scientific method can help you be right more often, and not just in science class. You just have to make sure you do all the steps. If you form a hypothesis without making any observations, then you really are just guessing. And you'll never know if your hypothesis is true or not without testing it with an experiment.